I'm here with Dr. Romano and Professor Blois to do a problem on simultaneous equations.
Hi, I'm Dr. Romano. I'm Professor of Organic Chemistry here at Romano Scientific and the creator of the Orgoman products and the author of the DAT Destroyer book. Many questions always surface, and kids are always asking me, could we do some more word problems? They never have enough. So Professor Blois is going to do 3 word problems. I believe it's 3, Professor, right? Mm-hmm. 3 word problems involving simultaneous equations that I think you'll enjoy. It'll be right on the money for the DAT exam. All right, Professor.
All right, here we go. 3 word problems. Let's read the first one together. The sum of 3 numbers is 160. The second number is 4 more than 3 times the first. The third number is 5 more than the second. Find the smallest number. All right, well, one way to start out is to assign letters to each of the numbers. So let's say we have the first and second and third. The sum of 3 numbers is 160. So the first plus second plus third is equal to 160. How about that for substitution of the variables, choice of variables? FST, first, second, and third. All right, let's see what other equations we have. Since we have 3 variables, we'll need 3 independent equations. If we don't have that, we can't solve it. So let's look for the next independent equation. The second number is 4 more than 3 times the first. Okay. So the second number is 4 more than, here's where the way I like to write that as I read it. If it's 4 more than something, it's something plus 4, then what? Then 3 times the first. And what else do we know? We need another independent equation. The third number is 5 more than the second. So the third number is 5 more than the second. So here are our 3 independent equations. Let's begin to solve. How about we proceed to eliminate, we want an equation in only one variable in order to solve this thing. We want to get it down to one variable. So how about we replace S in this initial equation with 3f plus 4. 3f plus 4. Okay, and we can replace t in that first equation with s plus 5, with s plus 5, and we know the sum is equal to 160. Now I wrote a space there because instead of writing s, we know that s is 3f plus 4, so I can replace this s with 3f plus 4. Okay. And now, what is the result of that? Look, we have an equation expressed only in terms of one variable. We are going to solve for f now. So let's add them up. F plus 3f is 4f plus 3f is 7f. So we have 7f plus, let's see, 4 plus 4 is 8, 8 plus 5 is 13. 13 is equal to 160. We'll subtract 13 from both sides. And we'll get what? What is 160 minus 13 is 147. And if we divide both sides by 7, we will get, let's use this space over here, we'll get f is equal to 21. All right, now, is that the smallest number? Find the smallest number. Is 21 the smallest number? Well, the second number is 4 more than 3 times the first. We can see that the second number is going to be more than 21. The third number is 5 more than the second, so that's even greater. So f is the smallest number. It's the first and the smallest number. Its value is 21. Problem finished. Okay. Let's go on to the next problem. Very similar. The sum of 2 numbers is 147. If the larger number is divided by the smaller number, the quotient is 2 and the remainder is 3. What is the smaller number? So it's a different kind of a word problem. And let's have the larger and smaller. The sum of 2 numbers is 47. Let's say we have the larger plus the smaller number is 147. Now, if the larger number is divided by the smaller number, so we'll have this. Larger divided by the smaller number, what do we have? The quotient is 2, and the remainder is 3. Well, what does that mean when the remainder is 3? The divisor is s, so this is really 2 plus 3 over s. Okay, that's the way to write that. The quotient is 2, the remainder is 3. What is the smaller number? So what we want to do here, how about we multiply this second number by s to get rid of the fractions? So I'm going to multiply both sides of this equation by s. All right, s on both sides, and that's going to give us L is equal to 2s plus 3. All right. So what do we want? The smaller number. So I see that L is equal to 2s plus 3, but L is also equal to 147 minus S. Okay, from the first equation, from L plus S equals 147, we know that L is equal to 147 minus S. We also know from the second equation that L is equal to 2S plus 3. We set L equal to L. Let's add S to both sides to get 3S. Let's subtract 3 from both sides to get 144. And therefore, S is equal to 144 divided by 3, and that's going to be what? 4, 8, 12. 3 goes into 24 8 times. There we have it. The value of S is 48. Problem finished. Okay, now on to the third one. A fancy dress costs $70 more than a plain dress. If the plain dress is 2/3 the cost of the fancy dress, how much does the fancy dress cost? Well, we have two unknowns, and we can see the two independent equations are pretty much articulated right there. Fancy dress costs $70 more than a plain dress. So, fancy dress costs $70 more than a plain dress. So the assignments need not be written out. There we know what the symbolism is. If the plain dress, okay, the plain dress is 2/3 the cost of the fancy dress, how much does the fancy dress cost? Okay, well, let's see. Two ways we can do this. We can set, let's see, we can set both. P is equal to, how about we do this? We'll find out what P is equal to. P is equal to 2/3 of F, which is also equal to F minus 70. F minus 70. Okay, we'll solve for F first, and then we'll go back and solve for P. So how do we solve for this? Let's multiply both sides of this equation by 3. That's one way to do it. If we multiply both sides of this equation by 3, we'll get 2F equals 3F minus 210. Subtract 3F from both sides, minus F equals minus 210. And we see that the fancy dress costs $210. Well, the plain dress costs 2/3 of that, so problem is solved. The plain dress costs 2/3 of 210. 3 goes into 210 70 times. The plain dress is 2 times 70, or $140. And there we have the problem solved. There we go.
I think it was a real solid problem. All 3 of them. But you know what I think the trickiest one was? About the one with the remainder.
Oh, yeah.
I think a lot of kids would think that was hard.
Oh, yeah.
The rest of them, I hope everybody agrees, is pretty straight up. Pretty straightforward. But
yeah.
I think with the one with the remainder was the trickiest of all.
It could be, yep. Yep.
All right. I hope you enjoyed that. And Professor Blois and I will be back with more solid DAT videos for you for free. Okay, guys. Bye-bye.